On to our Algebra 2. Today I will teach you this topic, how solve the exponential and logarithmic equation. All right. I will to divide my class in four sections. The first section I will explain it to you how solving exponential equation by rewriting the base, And this section, we have to remember this important rule. When you have a to the 0, this means it's equals 1, right? Important, remember that rule. All right. Let's see then to solve this. This is the first problem. 1 is equals 5 to the x power. How solving this question? Remember, 1 and 5 is we are able to rewrite it as a power of both power of 5. Okay, both 1 and 5, we are able to write it as a power of 5. Power of 5. In this case, we have, and then so for x, we have the first step. The next step here, we will write 5 to the 0. Remember this rule is equals how much? 1, right? I mean, not yet. It's just 5 to the 0 power. Let's write 5 to the x power, step by step. Here is like I told you, 1 is equals 5 to the 0 power. Okay, in this step. So here then 0 is equals x, right? So now set the exponentials x or the exponents equal. All right. In this case, our answer is so x is equal to 0, right? It is the solution. So let me show you another problem like this one. Problem number 2. Let's solve 1 equals 6 to the x power. So it's simple. It's very simple. No, it's not hard. Here we have to find how much is x. Okay. Again. So next step, 6 to the 0 is equals 6x to the 6 to the x power. So here set next step. This one is this rule. So 1 is equals 6 to the 0. So now set this is 0 equals 0 is equals x. So here is set the exponent equal, right? So the step by step, our answer is x is equal 0, right? Very simple. Let's do one more problem. So let's write 64 equals 8 to the x power. Let's see. Also, we have to find how much is x here. First step, let's write here 8 to the second power. Y is equal 64, right? 64. So this is 8 to the x power. All right, 8 to the x power. So this is mean that when you have 64 is equals 8 to the second power. That is the same thing. So now here 2 is equals x. So here set exponents, the exponent equal. The answer, so x is equals 2. All right, that's it for that section. Let me show you one more. The second section is about household exponential and logarithmic equation. So this was the section number 1. All right. Let's write so number 2, so exponential equation using logarithms. Okay, this section we have to use the logarithms. Let's write that one problem here. Write 61 equals e to the x power. To find the answer here, we have to round the answer to the nearest thousand, to the nearest thousand. Okay, so the answer will be about until 1,000. Okay, so here we have to remember in these problems the power property. We have to remember in this problem the power of property. Remember it? I show you the power property. So just I will to write it a little bit right here. This is a power property and log of m. So this is log m to the n power with the base b equals to n times log m with the base b. Okay. Another property that we have to remember here as the natural logarithms. So natural logarithms. We have to remember what is the natural logarithms. Just this is the symbol, right? In the way the natural logarithms. So this use the base e. So the thing base e. All right. I mean we have to write this way, log of x with the base e, and this way. So or logarithm natural logarithm of x, right? In this way. So also remember here the natural logarithm, we have the functions like logarithm, natural logarithm of x, or natural logarithms this way. We have to rewrite it. This is R inverse. This R inverse function. So natural logarithms of e to the x power is equals x and e natural logarithms of x equals x. All right, that kind of rules we have to remember. Just review, refresh some ideas to try to find the solution to this problem. So this problem 61 cannot be easily written or written in terms of the same base. Okay, so therefore we have to take the natural logarithms of both sides. We have to take the natural logarithms in both sides. Okay, so let's see here the next step. Let's write take the natural logarithm lateral logarithm in of both sides. So this is the step. So then we have natural logarithms of 61 equals natural logarithms of e to the x power. right? That's it. Now we have to use the power. I told you power property. Power property. So let's write here 61 equals x to natural logarithms of e. Okay. Now we will have here natural logarithms is equals e. I mean natural logarithms e equals 1. Right? So then we will have here, we have natural logarithms of 61 equals x. Right? So here, natural logarithms of 61 is equals, let's do it, and we have to use the calculator. So we will have here is natural logarithms 4.11087, right? So now, so to take, I told you to take the nearest 1,000, then we will have x equals 111, right? No, it's 4. We have 4 point. We have 4 point, so 4.111. That's the answer. All right. So this is one problem. Let's do another one. Let me show you another problem. I will solve a couple problems in each section. This second section's second problem. Let's write a to the x power equals 9. We have to find how much is x. All right. So here we have to take the common logarithms. Here, take the common logarithm. All right. Common logarithm is we have here log a to the x power log to the 9 logarithm. So natural logarithms in both sides, okay? Common logarithm both sides. Correct? Yeah. So now we have to use the power property. Power property, right? How I write it? The power property. So we have two here. So x log 9 divided by log 8. Here we have to divide both sides. So this is the answer. Divide both sides by log 8. Right? Log 8. That was the answer, right? So here we will have log 9 equals let's see how much is it. It's will be 0.95424. Yeah. And log also and log of 8, log on 8 is equal 0.9 0305. Oh no, it's 9. All right. So we have the answer there. So now divide it here. Just write the numbers. 0.95424 divided by 0.90309, right?
So this is if you divide this, I'm gonna use the calculator, right? Use technology. So the answer here we have 1.05604. 64. Okay. To the nearest 1,000 is we will have x equals 1.057. Okay, that's the answer. Okay, correct. Okay, two problems here in this section. Let me show you the section number 3. Section number 3. Let's write this topic is a solve logarithm or logarithmic equation. Logarithmic equation. So this is the level 1. So the next level is a little bit complex, but it's level 1. So let's write this problem. Log R equals 1. So we have to find how much is R. See? Here we have to define this with the base logarithm with the base b is defined here by this law. I just want to write the x to the base b. The base b. Remember, I explained it to you equals y. If only if b to the y is equals x. So this kind of rule we have to remember, and this capo the problem. Also, with the base b, we have log of x. The base just write always 10 equals y, right? Usually, we write log x equals y without the base, without write the base 10. You understand the base, the base. So after this, let's go and then solve our problem. So the question this is the form that I told you. This form is this form log x. I will write the equation here. Is this form, okay? With the base equals 10, right? It's this kind of problem. In this case, we have to write log r equals 1. So here r is equals 10 to the first power here. So r is equals 10, right? Just divide a little bit. So log r equals 1 log 10 equals 1. So plug in the solution. You plug the solution r equals 10, and in the problem, so the answer r equals 10 is a valid solution, right? So it's very simple. It is not hard. It's very it's not complex, very easy. Okay, let me show you another problem in this section. Another problem. Let's write when b logarithm of x equals 1. So we have to know or find, we have to work to know how much is x here. Same thing that I the first problem, I will not write it the whole process here. Just write here x is equals 10 to the first part, because this is the base with the base b. Remember, I saw you in the first problem. So x is equals 10. Very simple. Therefore, log of x equals 1. So log 10 equals 1. If we plug it in, solution, x is equals 10, the answer x equals 10 is a valid solution. Right? It's not confused. It's very simple. All right. Let me show you one more in this section, because I think this 1 and 2 is a very similarity. Number 3, let's write log x with the base 7 equals 2. Oh, this is a little bit different, right? So the question is the form. Log. Just for remember you, x with the base b equals y. So the question is this form. So therefore here we will have here x equals 7 to the second power, right? See, a little different. So x is equals 49, right? 7 times 7 is 49. So logarithm of x with the base 7 is equals 2. That's it. So therefore here log 49 with the base 7, so it's a little bit different, right? Is equals 2. So plug it in solution x equals 49. Our answers, so x equals 49 is a valid solution. Yeah, got it? It's very very easy. So this was the section number 3. Let's go to let me show you one more step section. It's a little more complex, but it's not complex since you got it this problem 4. So now solve logarithmic equation. So level 2. It is the same, but look at this. Remember the first one, now it's r plus 5. So it's equals 7. We have to find how much is, we have to work or to know how much is r. So again, the base, the logarithm is here, log x with the base is equals y. B to the y power is equals x. See, this is and also we have to remember the rules, common logarithms. Okay, so let's go. Here we have to isolate the logarithm. Isolate the logarithm. How? So we have to write here log r equals 2. Y is equals 2. 5 is plus right here. addition. We have to, when you move it to the right side, it's a subtract. So this means that 5, we have to subtract 5 in both sides. 7 minus 5 is equals 2, right? Well, you know, you are here, just write is equals 10 to the second power. So in this case, R is equals 100, right? See? So once you know log R plus 5 equals 7, and they mean logarithm of 100 plus 5 is equals 7. See? So plug it in the solution. R equals 100. The answer is, so R is equals 100 is a valid solution. Valid solution. See? That's it. This is let me show you, this is one problem. Let me show you one more problem here. A little more complex, but not hard. Let's let's write logarithms of W minus 9 let's let me W. Let's write a logarithm of T minus 9 with the base 15. With the base 15 equals negative 8. See? We have to know how much is T here. T. Okay, next step. First step is solve the logarithm. Okay, the first step. This is subtract. You move to the other side, to the right side, with as addition is will be positive the other side. So we will have logarithm T with the base 15 equals 1. 9 minus 8 is positive 1. So now rewrite this exponential equation. So here rewrite this exponential equation. All right, and then solve. So if we rewrite it, we have log T equals 1. So we will have T here equals 15 to the first power. So T is equals 15. Right? That's it. When you are here, I want to rewrite this as the process. Log T minus 9 with the base 15 equals negative 8. So log here, log 15 minus 9 with the base 15 here will be equals negative 8. So plug it in here in the solution. The solution T equals 15, right? T is equals 15 right there. Do you see? Then our answer is T equals 15 is a valid solution. So this is our answer to this problem, right? Let's write on one more in this section. One more problem here. Last one. Log W minus 9 equals negative 8. Almost the same the problem before. So now isolate the logarithm. Okay, isolate the logarithm. So if you do that, we will have log W here equals 1. So W is equals here 10 with, remember, the base B is always 10. So W is equals 10. Here, so log W minus 9 equals negative 8. Here, log with 10 minus 9 equals negative 8. So here, plug it in. Solution, and W equals 10. We will have W equals 10 is a valid solution, right? So that's it. Algebra 2 today. So thank you so much. I'm waiting for you the next class. I remember Monday and Thursday at 3 p.m. Monday 3 p.m. Thursday